Hey everyone, today I'm going to talk about the footprint of Marble Machine 3 because if we look at the previous machines, they were quite high, both of them. And the first one was non-modular, you couldn't take it apart. The second one was designed to be able to take it apart, to make it transportable. I do not want this design requirement for the machine I'm building now. So this machine is going to be transported in one piece. And I think I will be able to lower the height of this machine today. So in this stream, we are going to talk about the general footprint on a quite high level, and I'm going to fix it in CAD. And I will start every stream with making a notepad sketch. So everyone in chat knows what we're trying to do. Because in the last week's stream, we did that. The audience requested that, and the suggestions we had during the stream were great. So from now on, I'm going to give an overview of Notepad Sketch at the beginning of every stream. Then we're gonna go through the loop wheel size, loop wheel position, loop wheel clearance, resonator positions, prog wheel positions. I'm gonna check if my parametric CAD is working, and then we are done. So let's start with Notepad Sketch, but not before we have welcomed my friend Sir 3K. How are you today?
You know what? It's Monday. It's been far too long since I saw you, Martin, and I saw you there, the beautiful audience. You know, this stuff with weekends, what's that all about? Let's get ready to CAD, right?
I've never had weekends my whole life. Until now. Okay, so let's go to the sketchpad. So most of the things that the machine needs to fit in is kind of rectangular like this. And you can actually think of a shipping container, but you can also think of this box here, let me take another color, as a door opening. So my idea for the footprint of the machine is that we need it to fit in a rectangle like this. And as you can see here, the length is actually not important. So this distance, or the width, I should say, we can go crazy on the width, but it would be good if we can keep the height and so I guess length is the longest, no, the depth. So this is width, this is depth, and this is height. Okay. So let me just remove all this. So my idea for today is to kind of, since the wheels, these two big wheels are removable. And this was actually an idea from Hannes 3000.
Yahoo!
So if we think of the machine like this, and here's the feet, it's pretty cool because this depth measurement from here to here, depth, if we put these wheels off during transportation, we can actually reduce the depth with this whole part here. So that's what I'm gonna plan for today. And what we end up with is then this little rectangle here, the green thing. And right now the machine is 2 meters, 20 centimeters. And I think a normal door opening is quite much higher than that. So the only measurement that I will kind of ignore is this, the width.
Yeah.
So that's the plan for today. And I'm going to start working on it right now.
Oh, nice.
Hope everyone is having a nice time, and we had great response and great design suggestions last week. Been constantly thinking of the machine ever since, and hoping to get a lot done this week. I've also seen a lot of great suggestions in the design requirement document, and let's get into it.
Yeah, let's start. What's first thing? Where do we go from here?
Yeah, so if you see step 7 in today's stream, parametric check, is that's going to be a thing. Yeah, oh wait, I have it on the list. So we did the first one, so I'm going to play a mall. There we go.
Yeah.
And now we go to the loop wheel size. So I've been thinking about this wheel, and I think it's too big. Because I checked physically with this. I made kind of the wheel, I turn it around like this. And I just realized how fast it would spin, the wheel would spin. It will be quite aggressive. And right now it's 800 millimeters. And I checked standard sizes for these HDPE pipes. Next one down is 710. So let's start from the very beginning with our CAD skeleton. Let's go in there.
Alex Lohr says standard door is 203.2 centimeters.
203.
203.2.
Yeah, so I think arena doors and stuff will be higher, I hope.
Yeah.
Because 203 will be hard.
Yeah, otherwise we just bring the angle grinder and open up the doors a little bit, right?
Right now to this point is 2 meters, 20 centimeters. Yes.
Yeah.
Here's the measurement. Yeah, so we also have the door opening for like shipping containers. They are also not like super high.
Yeah.
So
could it be like if you take the wheels out, can you then tip the whole frame and like lay it down?
That it's an interesting idea.
Because then there's not a lot of fragile parts, right?
So basically what you would do is that you tip it over. I can't spin it. So basically you would tip it. Let me try if I can do that. That's an interesting idea, Sir 3K.
Sometimes they just happen, right?
Wait, it was there. It was right there. You mean like this, right?
Yeah. When the wheels are out, tip it that way. Let the frame take all the weight.
This is the coolest automobile I've ever seen.
That's brilliant, right? Woot woot.
It's like I can't drive it because the CAD is a little slow. This looks like this old school automobile.
Love it.
Pretty interesting. And I think something that I should really start to do.
Yeah, Lucas Wendel was on my point here as well. The height is only important if you need to transport MM3 upright. If you can lay it on its back or even side, which shouldn't be too difficult, moving it through doors should get a lot easier. You and me, Lucas. Wow, great minds, huh? Rabbit 128. Doors are temporary, glories forever. I hear you.
Yeah, it's basically right now. I think it's unnecessary high right now. So I'm just because I have a new idea that I don't have to have this space. I'm not gonna run the resonators from the vibraphone between the two drums. We can put them closer. So, you know what we should do? We should head over to the design requirement document.
How I've been waiting for this.
I've seen a lot of great stuff from a lot of people here, so I'm thanking you all for that. I'm going to go over. So I'm going to make my own little sketchpad by the end of it. And because I'm not going to write this now, but I want to do it later.
Yep.
So Martin's sketchpad. During transportation, requirement to be transported upright, question mark, requirement to be possible to lay down on back, question mark. Because that's a super good design requirement to kind of, sorry for that, to clarify. Play the mole by mistake.
Premature.
The mole itself became a mole.
I mean, then you could, as someone in chat said, you could add small wheels to the frame then. Take the drums out and then you have small wheels on the frame for it easier to roll in and out of storage.
Yeah, so basically you just attach
something
either
along the frame.
removable or permanent 4 wheels on this frame.
Yeah, there we go.
And I can also then take part in these Red Bull competitions and just...
If music fails, we always have that.
We can always go down in this downhill. I think that would be... Red Bull makes great videos, by the way. They of course have the budget, but I think there's some good persons behind their output.
Yeah.
Okay. So this is a creative idea. So regardless of the tilting, I don't want to make this machine unnecessarily big. So let's see what I can reduce without having to do a lot of trade-offs anyway. So this is the CAD skeleton, which everything is based on. And I'm now going to change the size of the loop drum to 710. But then I want to remove... How much did I remove here? I'm also going to machine off some surface. So from 900, we removed 8 millimeters here. So 702. And then the thickness, I'm just going to say for now, is this. Oh, I learned a click there. Minus 20. There we go. So...
Have you ever tasted such good coffee, by the way? It was brilliant today.
I use much less coffee today. It's so much weaker than what we normally drink. That's why you like it.
No.
You're getting weak.
You're outing me as a weakling here.
So let's now see. First of all, this loop wheel, can we lower it closer to the ground? Right now it's on 550. So how much clearance do we actually need? So
Clarence.
we got clearance. So basically, I've constrained it to the middle of the loop, and I don't think maybe that's the correct constraint. Maybe I should constrain the clearance from the ground. I'm gonna add a line here, and I'm gonna make this line tangential. So if you have any suggestions for today's topic, you can post them on the transportation Dropbox link. I think we have one.
Yeah, transport.
Transport is today's subject. And also, Hannes is keeping an eye on Discord, but we love for every suggestion to be made to the Dropbox for the archives.
It helps us so much to present everything from that folder.
So now I'm going to make a better constraint. I'm going to constrain the underside of the wheel to the ground. So then we need... This distance is going to be like the height of the programming pins on the loop wheel. So how high are those? Maximum 10 centimeters. So let's do 100 plus clearance. So how much clearance from the ground do we actually need with some adjusting feet? Let's do 50. So there we go. We made the wheel smaller and we moved it down a little bit. Let me save this. And let me see how much my CAD have been broken elsewhere. So this is where the CAD...
You just want those wins.
No. I'm going to...
I'm going to have to remove the buttons from you. Can't handle them, Martin.
Let me just try to switch again. No.
Whoa!
Wait. And now I'm going to switch. Okay, I fixed it. So now you can see when I go back to the main document, you can see that all the CAD needs to be updated.
Yeah.
Because I changed the main file. I'm going to try... This might I'm going to just try to press this button, and the risk for a crash is kind of a little ominous. I'm gonna try. So.
And Linus Öberg is quick here in chat. Watch out for the yellow snow.
Yep.
Oh yeah, computing the sweep. Dustin Sample says, before reducing the height of the machine, shouldn't we make sure there's enough slope for the marble path? I know that there was almost zero slope on the MMX, so consider this today.
So slope we're talking about. Yeah, so actually basically exactly what you're... Oh, this worked.
Nice.
Look, am I right to think that this wheel have moved now? Wait, did the frame also work? No, probably not. This moved. Okay, so to your question, the height, basically what I'm doing is that I'm creating more space for the marbles on the top.
Yeah.
So I'm not lowering, I'm just lowering the things that are underneath the things you're talking about. So to make it possible to have a good slope.
So yeah, it was a Gretzky comment right there.
Yeah.
Ahead of everything.
What you wanted is exactly what I'm trying to do.
Nice.
I played music, so I forgot to see if the wheel jumped.
But you entertained the masses.
Let's see here. 550. This wheel has not moved. So we have to now see a little bit. It's because of the joint. The belt has moved correctly. We have joined the drum.
Mm-hmm.
Drum is joined to something. So now I have to go and expose my bad CADing. Look here. This has broken because the frame is not parametric and this is gone. So let's start a repair journey.
Yes, bring out the duct tape. Here we go.
By going to the frame design and see what kind of sins I've made here. Oh yeah, I can see them long way. So basically here we can see that this position has followed nicely, actually, even though we have some blue there. Let me try to get rid of this blue. $12. So this should be 12. So you can see here that this thing is not extruded, it's been copied. That's why it's not parametric. So it's a copy. So let me think. How do I make this parametric? Let's start with removing this copy anyway. Delete. Then I'm going back in the timeline to where all this was created.
Ulrir Tvorfrey. Check if the crank position relative to the Martinator's hand is still okay. I love that new nickname, the Martinator.
It's a good name, actually.
Martinator.
I never get nicknames.
Sir CAD a lot.
Sir CAD a lot and the Martinator. So yeah, I basically used a stupid technique to copy this part. and I'm going to instead have a multi-body component, and I'm going to be fine with that. Oh yeah, I see why. This is not a plane because I'm missing a sketch line here. Let me fix that in the master sketch. You can see that the area is not blue. I missed that.
Ah, we want blue.
There we go, blue. So now when we're extruding this body, because I think I used this for the joint. Let's see here. There we go. I think this mirror command. Yeah, now everything works.
Oh, nice.
So a little repair. I'm going to go back and forth a lot. So now we go back to the main assembly. I'm going to update this frame.
Yeah. Woo! Fast today.
Yeah, and now the joint is broken, which is actually a good sign. Oh, I want to get rid of this also as well. Drum kit assembly.
Delete it.
Yeah. Did anyone see Duplantis? What's his name? The Swedish Pole.
Armand Duplantis.
Is it Duplantis?
Armand Duplantis.
I watched it with my father. It was a Swedish pole jumper who made world record like the other day on the third try, and I was like, it's going higher than he puts his goals high, failing the first 2 times. Like anyone?
Hint.
And just like no one, he couldn't even like try the first try, and like all the like. There was some like runners who made like this when they changed the stick. What's that called? Relay.
A relay, okay.
Relay. I'm gonna delete this. Oh, was this bad? No. So they were all like kind of watching him, and the people organizing the tournament couldn't like put the ribba. What's that in English? Like the little stick.
Yeah.
That you jump over. Oh, chat. What's the stick you jump over called?
And Ludwig says also it's pole vault jumper. Pole vault jumper.
What's the stick that you pass?
The bar.
Oh, thank you. The bar.
Probably. I'm just guessing right now.
They couldn't. It was like so high, so they couldn't even measure 6 meters, 20 centimeters or something. There was some. So he had to like wait for 100 hours, and then he just finished on the third try, and I was like, yeah, that's
stuck the landing on the third try.
That's a Marble Machine 3 right there. And now I was super inspired, actually. I never watched sports, but I did compete in 800 meters.
Yeah.
Anyway, let's fix this joint. Duplantis
style. And you didn't watch The Mountain versus the Beast then? How Thor versus Eddie Hall?
No, I heard you watch that.
Of course.
How was it?
It was better than I could have think of what I thought. I was like, this is gonna be silly as AF. But at least how Thor, you put the energy into it. He actually worked out for a year, slimmed down and learned some techniques. So it wasn't just like a boring like fake fight. It was almost two stars out of 5. Almost. Okay. Yeah.
Cool.
I was sure it was gonna be a 0.
What? 2 stars out of 5?
Yeah.
That sounds really close. So anyway, this loop wheel is in the correct space now. We have to make it smaller though. So I'm just checking this. Okay, so was it like scary to watch or was it fun?
What? Did you talk to me?
Yeah.
Oh, if it was fun, the fight.
Yeah.
Yeah.
Were they like nice to each other afterwards, or was
it? They actually had a moment of they thanked each other.
Okay.
They have been really nasty to each other. A part of the game.
That is just promotion.
Yeah, but I think they crossed the line a little bit too much late in the game there. It was getting really like, oh man, what are you doing? This is embarrassing.
So maybe it's some kind of boxing, right? I never heard about this.
It's so fun when you have like two of the most predominant, like world's strongest men. Both of them have done 500 kilo deadlifts, and then all of a sudden, we're gonna box each other. So you were thinking like, okay, one of them is gonna die.
So it's like Game of Thrones, but in real life.
Yeah, but as one could expect, they got tired after like one round. They don't have the stamina really.
Okay.
Do you know who has incredible stamina though?
Wilson.
No, Slice of Sparta. Height of the MM3 is going down, down, down. It would be even lower if you put it down inside the giant funnel. Let the good times roll. Save, hydrate, cheers. Cheers to you as well.
I saved it. I'm taking some coffee.
Okay, I will just have the cheers cam on. I will... must do a proper cheer. Cheers. Thank you, Sparta, as always.
Cheers.
That's how you know it's going to be a good day.
Yes. And now I'm going to reduce the size. So we have some success. The loop wheel is now in the correct position in the main assembly, and the frame is working. So the parametricness of the design is pretty okay. However, now we need to reduce the size of the loop wheel before moving on. So I'm going to remind myself of what I decided. I should make this a parameter, but I'm right. The reason I don't make this a parameter is that I get like, I have to find out a good name for it. So for now, I'm just going to take this 702 measurement. And if we go over to the loop wheel, we have it in, the loop wheel is like this. And I designed this super parametric, so let me just show you. Now we're in this design. And you can see the timeline is pretty busy. If you look down here, there's quite a lot of stuff, including a broken thing. So let me first repair. Let me do this good now. Let me check what this is about. Aha, it's this junk.
You have opened a door now, Martin, here. Jerk Rönnolds. What time did Martin do in 800 meters?
2:34.
2:34?
Yeah, it was my personal best. I was 12 years old or something.
12 years.
2:34. It's like sometimes when I see like some competitions, there's some people in the worst classes who are like not super much far ahead. Not bad. It's probably nothing too. It was always the last competition of the day.
Yeah. To me, Martin, you are a superstar.
Fantastic. Regardless the personal best in 800.
Yeah. I could never do that, you know.
Never say never. There we have more. So the thing here, the broken stuff here, is this ridiculous thing I did with this pulley here. So I think I can safely ignore that for now. Let me go back to this.
A super sweet message here from Cat. I love that name, Cat. I really love your laughter, both of yours. It's great to have you guys in the background when I'm working. Heart emoji.
That's so fun to hear. It's so fun.
It's so... you never get nice compliments from a cat. So I really love that. My cat never says those nice things to me.
So I'm in a little spot of bother here because I did this bad CADing on this thing, the pulley. And that's why we have these yellow things. You can't see them. They're hidden behind us. So I'm going to start to delete that bad CADing. Just see how much stuff is breaking. I just want to clean this up before... Okay, there we go. Now all the yellow is gone. And now then we can go back and do 702. And then when I go into our rectangular sketch, I have to do half of that because it's the radius. So let's see. 400 is instead going to be 702. But now it went all crazy because I have to divide it in half because it's the radius. Now I'm super curious. If this looks like it looked before but smaller, then I'm very, very proud. Computing, not perfect. We have an obvious issue with the spokes. So let's see how we can make this design more robust in a parametric sense. Not there.
Okay, chat is saying here now 234. Pretty good.
They like it?
You're pretty good, Martin.
Thank you. Yeah. So this is the obvious issue. Let me find out. Can I make a parameter on the fly here? Oh, look, I used this. D226. So I actually prepared for this. Why isn't it working then? I made a driven parameter, which is the inside D226. So now let's go and see why this is not working. D226. I have a feeling we've been here before. We were
We've been here before.
Yeah. Okay, so I can't use a parameter from one sketch to another. Let's create a parameter on the fly. So this is something someone from the US taught me through a super chat, so that was very nice. And I'm using it a lot since. So shout out to you if you remember. Parameter on the fly. Let's see. 329. How can I do this? Okay, you can never have a parameter that is changing. Okay, never mind. 329. I'm gonna do it manually.
Yes, do it.
Yeah, it's not. I'm not impressed with myself. 329. So this is. Yeah, but I have length here. Oh. 329 times 2. This is even wrong as well. Okay. D178.
And Lucas Pollard, my Wilson climbing the mountain t-shirt should be arriving today. Lucky day for you, and thank you so much for that support. You know when... Oh, look, Martin has it on him.
I'm wearing mine every day. I love it. I always feel like I'm like... I can do something when I put it on.
And I can just angle grind anything away.
Yep.
That's super nice of you. Ever since Martin decided to cancel the Patreon and YouTube members and the MMX last autumn, buying merch and doing the super chats, that's like the main ways you can support us these days, and it means the world to us. So nice to see you ordering our shirts.
Yeah, thank you so much.
And being supportive.
It's wonderful, and even more wonderful that this is now working. My model is not super parametric. I think I'm gonna make like... So now, if you can see here, I'm gonna update this. And you should see the wheel getting smaller. There we go. This looks fun. I don't care. It's okay.
And Bob Bear, hi, I just discovered your fascinating project. And he continues here. I was crushed when I found out MX didn't work out, but I'm immensely happy you're creating a third machine.
That's so fun to hear.
Yeah, love that. Thank you so much.
I think on the first machine, I tried the idea. On the second machine, I learned engineering a little bit, at least. I learned enough to understand how little I knew. So this is third time's the charm, and super happy to have you in the project. Everyone who is here right now, you are all awesome, because this project is so much delayed gratification and so little clickbait. So everyone who is here now, I'm very impressed that you're following in the kind of the Rocky Balboa. We've been beaten twice. But we are coming back for the final fight.
Yeah, you're the hardcore viewers. We love you all.
Yep. So now you can see we have extreme amount of space here. And I actually love the fact that the lower drum is smaller than the higher drum, that you can see a real difference. So I really like where this is going. And now I'm going to start moving down the top drum. And we're going to start by removing this brace. This brace made it impossible anyway to install this belt. So let's start removing the brace. That should be very, very simple. I'm just going to go here and delete this feature. I'm going to delete also the component. So let's save that. Let's go back and update, and the brace should magically disappear. I was inspired watching the athletes in this track and field like world championships, because they are really only doing point one on their to-do list, kind of. Of course, they are doing like some commercial stuff with sponsorships and stuff, but I think these athletes, I think they make their life just about training. So Duplantis, like everything is about being able to pass the bar higher up every day. I was so inspired. I was like, yeah, that's the mindset I want for this project as well.
Yeah. And then they have their couple of years when they do that, and then they retire. So perhaps now, Martin, you are in your prime now, your athletic prime with marble machines. This is now or never. Now we're gonna take all the medals.
Yeah, this is
later comes retirement from this stuff.
This is now or never, because if this CAD model is not promising, I'm gonna finally give up on the whole project. So let's see. Now we can. So here we come to something that I want to talk to everyone about. This frame is tilted forwards. You can see it has some kind of lean. And there's actually no reason for that. So if we go back to the sketchpad.
Oh, yeah.
If we're going to do this thing where we're going to try to... I'm going to show you here. We're going to try to reduce the sideways footprint. So here I'm going to have a tilted frame like this, and a small drum and a big drum. And here, my new alternative for delay, straight frame and the drums exactly on top of each other. And here comes my point. If we're going to find the clearance rectangle, it's by this frame. So here's the rectangle for this machine, and here's the rectangle for this machine. And as you can see, let's name them A and B. And in version B, kind of we move it's much more space efficient, like inside the container wall or whatever we can call it. So I just realized that this tilt in these two wheels is actually annoying. It looks nice, but form from function absolutism gives us that in theory the center of these two programming wheels should be on a vertical line, just to max out, because as you know, when we remove the wheels, we don't have these things sticking out. So in alternative B, we make much more space, and we also move everything further to the right, which means that we can probably have less stuff sticking out here in the front. So,
and chat is saying a lot about keep in mind the center of gravity with these variants.
Yep, it's not gonna be an issue. I can sketch that as well, actually. Let me take a new file. So if we make it very clear, so here we have 2 feet, and we make a frame like this. Tick, 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 tick. And if we add the wheels actually on outside center of gravity here, it looks like it's going to fall. But these 2 empty wheels is the only thing on this side, outside center of gravity. The rest of the machine is going to be here. All the other weight is going to be here. So I think we're gonna have a very clear center of gravity close to the middle here somewhere.
Boom.
Boom. So let's go back to the skeleton.
And Ludwig says here, have you read How to Skate 10K? I think Nils van der Poel could teach Martin a thing or two. Have you heard about that?
Yeah, Nils van der Poel is the skater from Trollhättan.
Yeah.
And I didn't know about the book, but
he released a manifesto.
Okay,
Yeah.
that's very interesting.
It was the talk of the town.
That's very
immediately after the Olympic gold medal. Like, this is how I did it. And a lot of people, their minds were like...
Is it short or is it long?
Semi-longish.
Yeah, it's a live stream. We have to read it on a live stream.
Oh yeah, 1 chapter a day.
Let's do that. Cool tip. What was the name?
Nils van der Poel.
Yeah. But what's the name of the
Ludwig?
What's the name of the book? Third time's the charm. If you get it right, you get a good signal.
How to skate 10K. Thank you, sir. I got there.
How to skate 10K. Nils van der Poel. Super interesting. I know van der Poel has a lot of philosophy behind.
I think it could be really interesting with the whole consistency of everything and the dedication and his mindset towards it all. It could be kind of applicable in a lot of things in life.
Amazing tip. Thank you. So, according to my theory, this is the CAD skeleton. We have to move this loop wheel back to where this wheel is. So let's do that. As easy as that. And
the manifesto is around 1 hour to read, so not that long.
Okay, cool. We should do it on a stream, actually. It's fun. Let me see how I should constrain this. Should I move? So this is on the origin line. Yeah, instead of moving the programming wheel, how should I do this? What will be best? No, I think I'm gonna move the programming wheel back. So I'm gonna remove this constraint. So Fusion is okay. I'm gonna remove this constraint. So this sketch rules everything. So I'm gonna make a line. It's just a little bit easier. I don't even need this line. And I'm going to tell the top wheel that your center is completely vertical above the bottom wheel. And now we can determine. And instead of giving the distance center to center, because that's not really what I'm after, I'm going to make 2 tangential lines, and I'm gonna have constraining the space between the wheels. It just makes more sense.
The manifesto starts with a Carl Jung quote.
Oh, I love Carl Jung. Is it true?
It just starts with, "It seems that all true things must change, and only that which changes remains true." Here we go.
So it's fun. I have family in Netherlands, and Niels van der Poel was super famous. Skating is bigger than, it's their Super Bowl, like in the Netherlands. They win everything. And Niels van der Poel was so popular, but there was so much drama during the Olympics because Niels van der Poel claimed that Niels van der Poel also have Dutch heritage. And Van der Poel claimed that the Dutch coaches were kind of trying to make the ice, the quality of the ice to fit their skaters.
Yeah.
And so on a dime, all of the Dutch people just flipped on Niels van der Poel and hated that he won because of that. Okay, so now I'm going to give the clearance between the two wheels here. And I'm thinking programming pin, 10 millimeter, plus loop programming, 100 millimeter, plus 3 centimeters clearance.
My dear friend?
Yep.
Do you want some more thinking oil?
No, I have, thank you.
Do you want me to warm it for you?
It sounds like I'm so bossy when you say that.
No.
Like, do you want me to? Yes.
I will warm it.
So 140, that's actually too much clearance. Let's be a little bit rock and roll here with our clearance. So now we have a new position of the main wheel. And I actually see in our to-do list that we already did the second one.
Woo,
and we did the third one. We did the fourth one. And we're actually now on step 5 already. So let me play that mall and then quickly just mention why I wrote resonator position in the to-do list. Because I thought that the resonators from the Vibraphone would go through the open space here between these two big wheels. And I've decided, no. It's much better they go straight down here somewhere or somewhere else. So that's why I'm now going to move the two wheels closer to each other. And now I've done that, so let's update and see what happens. A lot of things will break now, I think, but we will fix them. So this is our computing screen. With some waiting music. There we go, we're done. Oh, I didn't mean to play that. I have to learn how to make that not happen. And what happened here? So, good news, the wheel is in the perfect position. Oh, I kind of like how that looks. And the frame is broken, we're gonna fix that. I kind of actually like how the two wheels straight up like that looks. Look how close it was that the frame actually almost was parametric enough. We have some issues with the frame. Let's go and fix the frame real quick. So you can see the frame kind of died. Is this the only issue we had? So you can see that this line is not connected anymore. Later in this project, why is that not working? Yeah, that is working. Later in this project, I will Oh, you know what? Go through everything and make everything more and more parametric. It's just I feel there's a trade-off when I'm designing, that if I try to make all the CAD great while designing, I just because I'm really just sketching right now. I'm not creating the CAD that will become the file that the manufacturers use to build the parts. Basically, what I'm trying to find out is the design requirements. Look here, I can already see that we can lower with 20 centimeters. Woohoo! Oh, that looks great. So here's our new simplified frame. Was not that much to fix in CAD. Oh, thank you, Hannes. Sir, 3K.
Woo!
Let's see what happens here. 200. No. $900. Just trying to get the foot under there. I should make this parametric as well. That's for later. I thought I would hate this 90-degree thing. I think it looks super pragmatic. What do you think?
Excuse me, tell again?
No, I'm just saying that I thought I would hate the frame standing straight up like this.
Yeah.
But I really like it.
Yeah.
What
Keep
happened?
it simple.
Exactly. Okay, we have some more issues. But I just fixed that. Ah, it was a save. Ah, okay. So something happened here. So let me fix this again. Finish sketch. I wish that Fusion would allow me to make a Swedish sketch. Now let's do this. 2 meters instead of... So we chopped off 20 centimeters. Here we go.
Oh, 20 centimeters, that's quite a lot.
So someone asked before we need more space for the marbles, and now we have 20 more centimeters of space for the marbles.
Brilliant.
So let me fix this little foot.
Writers on the wall garden. Please do the math on how many marbles you need to lift per second.
Yep.
Is that something?
Good point.
Oh, that sounds difficult.
Yeah, but very good point.
That's a little bit in the future, but...
Yeah, but this is a like perfect example of... and a lot of people pointed this out, but I'm thankful that you did again. Marble lift per... I think actually it's going to be crank turn, not second. Per crank turn. DR design requirement.
Yeah.
So if the person who recommended Niels van der Poel, I'm curious, what did you like with it? Or
yeah, please
tell us your thoughts about it. How to skate 10K.
The full title is How to Skate a 10K and also a half a 10K. So fun. ... and also half a 10K.
Well, look at this efficiency. So we should let's do the what was I called? It looks so cute now, the little machine. Look.
Yeah, it looks like will fit in a pocket now.
Yeah. The Martintron.
Oh yeah,
What's the name?
No. Martinator.
And also now you can see that we can, when we take this off. So this flywheel needs to move as well later.
Mm-hmm.
Because if that's going to be left on the machine, I wanna put it forward.
Yep.
Or put it off. We'll see. Yeah, I like this. I think I like this. Because also now when we have the programming wheel more to the right, if we look at it from the top, we see more of the vibraphone.
Ah, sweet.
Yeah, so otherwise the wheel was in the way here. You know what?
Yeah, we're getting there. We're getting there.
We're done with prog wheel position. So, boom. Yay. Yeah, I think this looks better. There is a point to be made that maybe we have to design for a brace down here. I've been thinking about this.
Underneath the loop drum?
Yeah.
I mean, that would work, right?
But I'm also not sure if is it absolutely necessary?
All the stability can't hurt, right?
No, but then since we want the programming pin sticking out from the loop drum.
Oh, yeah. Okay, yeah.
It does.
But totally in the bottom there, it should have clearance, right?
Yeah, but these feet are, what is it called? Adjustable. So this is something I've been racking my brain about, that if we go to the frame, look at this, if we can have this here. If all these are welds, no, I don't think we need it. I think the frame will be ridiculously stiff anyway. And worst case scenario, we connect down here with something at a later stage. Perhaps.
Yeah.
Perhaps something flat.
Just tie it down like you do with a tent.
You want some tent pegs around it?
Yeah.
A little bonfire and a guitar?
Yes. Kumbaya, here we go.
Well, can it play Kumbaya?
Can I play Wonderwall?
Yes, I'm pretty excited about this. I'm surprised that this design hasn't followed suit though. What? So now we move in. We did number 6. Let's move into step number 7, parametric check. And let's start with our esoteric assembly, the registrators. This is the last stream we did and it was really cool. I'm gonna show you why here. Open. So these levers are Bowden cables and they are bidirectional. So when I put the lever up and when I put it down, it does two different things. So it rotates this camshaft here. So this is just clumsy, the Bowden cable end. And it will mute and unmute 2 channels per channel, which means that we can have double length programming of the music, like last week's summary. And having this in a Bowden system is so much simplified. It means that I can put these levers wherever I want on the machine. I can just put them, I can put them 200 meters away if I want, in which direction ever I want.
Yeah.
So it's pretty epic. And what's not so epic is that this assembly has not changed space. So some master sketch has not been created correctly. So let's roll the timeline back to the very beginning and see where I've been cheating. I'm rolling forward. So this is here we go. Is this the new master sketch? Yes, this is the new master sketch, and it's yellow, which is our first clue. Turn off object visibility for sketches. Okay, so the purple thing has... Okay, so here we can see what has gone wrong. This point has not been... they've been constrained to each other. Do you remember, Hannes, that I used to talk about the concentric command?
Yep.
So instead of constraining things to a point in a circle, try to rather use the concentric command to know for sure that these middle points are the same and that these circles will move together.
Yep.
So this is almost related to me not doing that. So let me just see if I can fix this. So all of you are constrained to you. No. Let me remove this. Oh, it snapped into place. Here we go. And all these crazy Bowden cables. Let me fix that. Why can't I? Let me just delete you for now. This was a murky sketch. Anyway. And now, if we go back, what happened here? Oh, the springs. Now, if we go back to our model, I think the registrator has followed. So the thing is that if we put the machine on the back, then it's the width of the door that will be the limiting thing for transportation. But probably then if we have double doors, yeah, that could work. Oh, our registrators did follow correctly. Nice. Well, what are people saying? Any suggestions? Anything? I'm actually done.
Here are a few things.
I'm checking through Dropbox there.
Oh, cool. I'm actually done, Hannes.
That Rasmus triangles, the way to stabilize everything. You're done, are you saying here?
Triangles. Yeah, for example, regarding the triangle idea, just realized something. Who said triangles?
That Rasmus.
So I'm just gonna make a note here, Rasmus. That Rasmus. Base cross. That we eventually could do something like this. Let me just here. Maybe, if we really wanted to, we could make a cross like this. 40. Now I'm gonna try to be smart. This could actually be nice. Oh, wait. You and you. I'm gonna make a bottom stabilizer cross real quick. So mirror you over you. Mirror all of you over you. And then
I saw someone in chat saying earlier, cross bracing doesn't always need to be like an X or something. You can also have U-shaped bracing.
that's interesting.
See if I can find who said it.
And I'm mirroring everything. I mirror all this over the...
Brandon Wheeler, your cross brace doesn't need to go directly in between the uprights. It can come out like a U.
Ah. Around the wheel, you mean?
Yeah.
Yeah, that's true. Especially on the lower thing. That could be true. That's a good point. I'm just making why can't I? Is this not working? No, it's not working. Never mind. Okay, now it's working good. I just want to make a note of a potential pretty ugly cross brace. But if we for some reason need some, I think the welded frame will be super stable. You could have something like that. That's ugly. Like Christmas tree foot.
Well,
Form from function.
yeah, if that is what it takes, it is what it takes.
Yeah, that's true. We're not gonna be embarrassed. Oh, I wanted a lot of pedals and stuff down there. I didn't think of that. This will be in the way. I'm just gonna leave it in there for...
Cody Wheeland, how about some guide pipes for forklift tines? Even if you use a different method of lifting, that is a worldwide standard interface for moving large, heavy objects.
That's a good point. We heard it before. It's a very, very good point. I think this should be a design requirement. So what I've learned a lot regarding design requirement is that they should be design agnostic. So I'm gonna take this very good comment and I put standardized lifting fittings, places for lifting equipment. So I'm just making a note. This is not a requirement.
Yep.
Places for lifting equipment, and in parentheses, EE, forklift, question mark. So now I mentioned forklift.
Yeah.
That's basically forbidden, I think. If that's not exact requirement, I should not talk about what kind of lifting fittings before I know that in the design requirements. But it's an interesting thing to include. There. So...
And as chat is saying, the cross bracing at the bottom is not visible from the crowd anyway.
Nah, that's true. That's true. That's very true. I don't think we will need it, but I just wanted to show
That's one way to do it.
there might be place there. Okay, cool. So what?
Wow, you were so fast today, Martin.
No, not. Well, it was a very simple thing. And I get a better feeling for how parametric the model is and isn't. And that's going to be later when we get a little more clarity of what we're actually building.
Yeah.
I'm going to make it more and more parametric. But for now, I think, yeah.
And the chat has been saying a lot of times this day and other days, so talking about the belt. When is it time to start thinking about that whole shebang?
In what regard?
It doesn't come off right now. The frame is in the way, right?
No, it was before I removed the cross bracing.
Okay.
I took that part away. So we fixed that problem today.
Okay. You see, I am vigilant.
Yeah, that's perfect. Perfect. So the major, so let's talk. I'm gonna think loud about next steps.
Yes.
I can go into detail on a lot of parts on the machine, but I think like the next thing that I really need to know is kind of how many. I think I need to start to make the design requirements for the Vibraphone.
Okay. Yeah.
So
I can just, from the temperature of the chat during the last couple of days, feel people are so looking forward to the whole marble distribution. Like if you're on top of the machine and the transportation of the marbles, how that's gonna work.
Yeah, so that's definitely for later for me. So I think like instrument positions and number of instruments, number of channels is much more fundamental. So before I know where I need marbles and how many I need, I feel that it's jumping the gun to start to. Oh, sorry, what is?
Well,
it's jumping the gun to start to design that.
Okay. Marbles are the least important thing on this machine.
Thank you for putting fuel on the fire. No,
I understand you. Totally worthless right now.
Well,
we need to know what the marbles gonna have to do.
There we go. Design requirement thinking. This is a user story. The why.
Yeah.
So the why of the marbles, and I think maybe I'm gonna take this opportunity to think a little bit out loud about. So the thing that I see is the next fork in the road here.
Yoshik V. Tumane symbol interfere with the bracing. So you have one thing immediate that you can fix, the symbol.
Also, the kick drum interferes with the bass. Let's
tidy it up.
Let's fix that for fun. Eagle eye in the chat. So that should be pretty instantaneous. So here's a trick that I've shown a lot of times. First of all, you have to have show sketches. And if I show this sketch, and if I take show dimension here, we can see the dimensions even though we don't go into the sketch. So we saw in this image that if I just put the symbol a little bit higher, we will have better clearance. So by showing the dimensions, I can do this right here. So I just go into this little 200 millimeters and I say 300. Boom.
Ba boom.
Symbol is higher. And if we upgrade in the main assembly, we should see this clearance disappears. So let's update and save.
Yes.
So this model is still like super blocky, super sketchy. So trying to figure out like what the machine we are going to build is, and I think what I need to actually get a little bit to the bottom is the vibraphone. And so let's head over. I'm going to actually pivot a little bit to subject and just continue in this stream. And I'm going to talk about the design requirements for the vibraphone. Anyway, the design requirements that needs to be... I'm just gonna note down what I have to think about, because I've been thinking during the weekend about this. Vibraphone D.R. Let me actually blow this up for you.
Oh, thank you. Crystal clear.
That's crystal clear, right?
Yeah.
So, note repeatability is a big thing.
And a big word.
How fast a note can be repeated. So the classic example is good, I can't even play it. So we have the note D there. It repeats pretty quick. So if the machine can't repeat a note twice fast, that melody would sound... yeah, it would not sound right. So note repeatability, important. Oh, actually, we can stay on this screen a little bit, maybe. How fast a note can be repeated. And this is design agnostic. There's different ways to reach a higher note repeatability. Now let's go back to the document, by the way. One more time. Same button. Nice. The next big thing is how big scale in one song. That's bad English, but no. How what is it called? Spectrum, scale,
Range.
Oh, thank you. Note range. Note range in one song. And with that, let me see what I'm doing here. Note range in one song. So notes are replaceable. Question mark. Resonators are tunable. Question mark. But these are more design questions. This is actually not design agnostic.
Mm-hmm.
So basically, these two things, these two design requirements is determining so much for this machine going forward. So like full scale vibraphone. So, and I'm really kind of stuck here.
Mm-hmm. What is bothering you with this, my friend?
Thank you for asking. Well, I know my dream requirements. Maybe that's where we should start.
Yes, exactly what I was gonna say. What do you want? First and foremost.
My therapist used to say like, if there's no limits, whatever, like in universe, neither like physical, nothing with reality, how would you spend your day?
Mm.
And it's kind of like, and I'm like, I would be here with chat, with Sir 3K, writing Vibraphone design requirements.
Yeah, dreaming big. Dreaming about a full-scale vibraphone.
So
Yahoo!
okay, so dream requirements done.
I love this. This is the best.
Dream requirements. It's actually pretty humble.
Okay.
Are you ready?
Okay. Yeah. Bring it. Let's see how big you can dream.
Full scale vibraphone. F4 to F7, I think it is. F7, 37 notes. Or is it F8?
Actually, for later in this year, Desert Pillar has a nice little suggestion. Maybe do a pros and cons. That's also great. When we have the dream finished.
Yep.
Get on with your dreaming, my friend.
That's it. No, it's a great idea. And I'm actually, we can't do things that is not in the list. So I'm going to put in the list.
Dream.
Extra. Vibra design requirement. So that's what we're doing right now. I think it's F4 to F7. F4, F5, F6, F7. Yeah, that's correct. And I want same repeatability as on MMX.
Yes.
Double release per note. So I kind of promised myself to only have one marble per note on this machine because I wanted it much simpler. And since then I've been thinking like, can you find the episode with Amelie from Montmartre music?
Oh, when the machine plays?
No, we're gonna get copyright striked, maybe.
Oh.
You can go check it. The machine plays fast. And I'm just thinking it would be such a shame if we can't even play the original Marble Machine melody. Because that is faster than you think. To have that, to be able to play that melody, so there's two ways. So let's attack one of these. So let's talk about repeatability first.
And speaking about repeatability, Slice of Sparta with another super chat here our way.
Wow.
All this planning and documentation warms my heart. You guys are doing this machine the right way. Don't forget small scale testing. Cheers. Cheers to you as well, Sparta.
Small scale testing is a small scale testing. I'm gonna write it down. You're absolutely right. I'm thinking it could be cool to 3D print in like 1/20 scale or something like that.
Yeah.
I'm just gonna write it there. Good idea. Repeatability. I love the fact that when I'm in the text documents, we get so much credit from this intelligent audience.
Yeah, they know this is where the real work gets done.
Because I've been like feeling maybe it's more fun to see CAD, but people react so positive when they see work in these documents. It's fun. So let's talk about repeatability first, and then the scale later. So repeatability can be achieved in two different ways. A, 2 marble releases per note. Or B, 2 notes per note. two how should I say that? 2 vibraphone bars. So I mean 2 vibraphone bars per note.
Okay.
But let's do some quick reality check here now. Because 37 notes times 2 marble releases times 2 music programs is not going to be a nice answer.
You want me?
No, I can do it. 37 times 2, 74 times 2, 148. 148.
$148 what?
Yeah, it's actually 148. What was half? 37 times 2. I can't do that in my head. 74. So it's 74 channels, 148 registrators. So yeah, it's kind of crazy. It would be so cool.
How many registrators were on the MMX?
38.
Whoa, okay. Yeah.
But these are much smaller. These are much smaller. So it's more comparable to this.
Okay.
But that was for the whole machine, right? This is only for one instrument. So
this is only for Vibraphone.
Yeah.
Ooh.
So no, repeatability can be achieved in 3 different ways. 2 marble releases per note. B, 2 vibraphone bars per note. C, exchangeable vibraphone bars.
Like on the MMX?
Yeah, so double note you want to be repeated. So if you want this, then you just put 2 of the Ds next to each other, and there you go.
Kind of a hassle to set up, but not really if you know what needs to be played.
Yeah, so that comes with like the switching between songs design requirement. So switching between songs DR. Switching from song 1 to song 2 shall take no more than X minutes. So that's kind of, so if we have to tune all the vibraphone resonators or switch out the pipes, yeah. So this is like where, of course, we have a big multiple on this 37. So remember we only had 11 on Marble Machine X. So like if we take this number down, our life becomes much easier. So then we have this idea that we could skip this top row and only use the lower row of bars. And this is where I don't know what I want.
David Brooks says method 4, just speed up the action of the registrators.
Good one. And if it's speed up action of marble release. So you also have to speed up the feeding action. We had some good, but something that I do feel is true from my experience with Marble Machine X is that if you drop the marble before it's resting, you're gonna have a less precise drop. So what you want, I can show this in full screen. So like if this ball is resting and I drop it, it will drop like in a repeated fashion. But if it comes down and drops right away, it's not going to be dropped in a repeatable manner. So if we only have one channel, we're kind of like I think it's very to speed one track up to be able to play. In that little time, one marble has to disappear, another marble has to take its place and lie still. And I'm sure the second note there wouldn't be really tight. Well, when we have two, that's why I built two on the first machines, you can play this like super impressive patterns. Like, things like that.
Des enfant. What about a mallet for secondary note for certain double/fast instances?
Can you read that again?
What about a mallet for secondary note for certain double/fast instances? So like, then we can have on all the instruments, like we have on the drums, you have the beaters. You can have the like mallet for the vibraphone as well. So some of them plays with mallets and some plays with marbles. And we get a mini kinetic fingers going right here.
Then you want mallets for. Then you need mallets for all channels of the vibraphone.
Yeah. As you can hear here, I'm just sitting here dreaming as well.
No. This is great. Nothing is wrong here. This is the John Cleese when the joke is being made, but it's not a joke. The first time of free creativity. Mallets for high repetition. Good outside the box thinking. Repetition. These are not design requirements, so don't freak out that we're using the document right now.
No, this is sketching.
So if I went back to small marbles, yeah, I would like to use these bigger ones. These are 30 millimeters. I would even like to use 40 because it would look so nice and it will feel better. I think I can create a better sound in the vibraphone.
Inuyasha Martin, how about a reflect plate that made a marble hit a second time on the same drop? Reflect plate.
Wow, that's I'm gonna write that down. That's very creative. So then you would need to like put the plate in and out for repeated, and then how to do. Wow, that's a cool outside the box thinking. Reflecting plate, marble hits twice. Hard to maintain. So the marble would actually bounce off the second time. So the marble comes down, hit the plate, and hits something and reflects it. And then it kind of maybe just would start to roll on the plate. Super cool idea though. Yeah, so this is... So probably there's a trade-off somewhere here, because if I lower the scale, I can give it more repeatability. Or Hannes.
Or
we just realized that we're beyond crazy already and do what we've talked about this whole time. We just make the machine wider.
Okay, yes.
We just say like, okay, now we've been responsible in this direction. Let's be irresponsible in this direction. Does that make sense?
Yes. Yeah. Whack it.
That was by mistake again.
Mike says, hi, what about 38 channels plus X channels dedicated to repeated notes?
Yeah. So this is a very pragmatic approach. I just want to note it down. Um, mm, mm, mm. And they can be interchangeable. EF.
G?
Genius. G as in genius. 37 standard channels plus extra spots for repeated notes. So what you can do here then is non-tunable plus extra spots for repeated notes. And if they are going to be changeable, these has to be tunable. You know what? Because this has been on my mind. You know why this is so pragmatic? Because this part, they will have one dropper per track, one dropper per vibraphone plate. This will also have one dropper per vibraphone plate, which is like one of the fundamental things that I wanted to drop the marble straight down and not guide them on this machine. So basically, you will have less stuff being unused. So this will always be you will have less firepower on the machine that is very seldom used.
You know what? Mandracule just came in with a question and a generous support here, so let's hear it. What about replacing the entire vibraphone like the programming wheels? Or having modules that contain a note and a resonator together which you can slot in?
Ooh, so you're making
some vibraphone templates. You have different vibraphones.
Basically, I kind of like this. Basically, so let's go to the sketchpad. Here. That's a cool suggestion, Mandracule. So basically, let's say that we have. It's also like in the vein of being able to be prepared off the machine.
Yeah.
Actually, really nice. I didn't think of this. So good one. So just stylized here like this. And the resonators are on as well. Wait, I have to give it a church organ pattern. So this whole thing is a module. So you can just grab it by your hands like this and take it off the machine.
Yeah.
Or on the machine, and you can just slot it. You can just slot it straight in. It's very pragmatic.
Yeah. So you have your Marble Machine song vibraphone and you have your Daft Punk vibraphone.
Yeah, and most of all, you only need two frames. So you change them. You can't make one per song because I can't afford that. But if you have 2 frames, you prepare it off the machine.
Oh, yeah. You can change the plates and resonate the pipes.
So
yes.
Over here is the technicians preparing the other one. And then you just switch them. Just like the programming wheel. So we have 2 sets of everything. So instead of like, we have to put 20 tubes in while the audience is like, of course I can play guitar solo. Now we can play songs with the band also. So this would definitely be the way. This is nice, Mandracule. If we make no standard positions, if we just make one line, this would be the way to do that. It's a great idea. What was the other idea? It was
And-
2 ideas in there.
Hendrik Orre, a modular vibraphone can also save shipping the container space. Now you can take it off the machine.
Yeah, I think maybe not so much because the other instruments are in front. So if we think of the rectangle, if we go back to CAD. So if we think of the rectangle, since the vibraphone is in the middle,
When will you learn?
it's the program, it's not me.
Oh yeah.
I think I have to play. What I think I have to do, I have to play all 3 moles before the stream, and then I have to make them so they're not engaged, and then we won't have this. I'm gonna learn to the next stream. People are gonna miss them.
This is a learning curve. Let's read the whole suggestion from Modular again. What about replacing the entire vibraphone, like the programming wheels, or having modules that contain a note and a resonator together, which you can slot in?
Yeah, I definitely like your first idea there. And so if we look from the top here. Okay, how many notes do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Let's make a song and let's count how many notes we need.
Let's make a song.
Let's go to the split screen. And so let's check the pause music, okay? So we've been playing this 1, 2, 3, 4, 5, 6, 7, 8, 9. Am I on 9? 10, 11, 12, I think. No, I had a 1. 11, 13, 14, 15, 16, 17. No. And if I want to do 18, 19. And then since we have so much program, I've been talking about key changes. Here's like 21, 20, 21, 22, 23. And this one, 24. I want a lot of notes. I'm like on 24 already. So we're already past like the bottom row here.
Yeah. And a quick question here. People want to send in sketches about this issue. Where should they put them? Is instrument placement a good folder for now?
Should I create a Vibraphone one? I know how to create the correct one. Do we have something for the Vibraphone? I think I'm gonna make one. Because I know how to make it now.
So hold up, chat. There will be a new folder coming soon.
We need more folders anyway.
More of them. All folders.
Yeah, what was the closest one we had before? New, let's see here. Instrument, placements. Yeah, no, we definitely need...
This is gonna be an ongoing thing, the Vibraphone.
Yeah,
Delicate matter.
Let's make a Vibraphone folder.
Let's do it, people.
Vibraphone new, and I'm going to send request files. I'm doing it the right way this time, Hannes.
Oh, thank you. So I don't get cranky.
Vibraphone, yeah. that was a hard time last time.
We don't want that repeated, do we? Hannes versus Dropbox.
We almost broke up the band. Let's see here. Let's see.
Nikita Lvov. Idea suggestion. Maybe create a marble registrator in that way, that it should auto switch between left and right marble release. So this design will use one input from programming wheel and it will play fast.
I see what you mean. Yeah, that's basically two. Yeah, that's the double drop. We still need to solve the double drop. Vibraphone Design Suggestions. So, Sir 3K, you got mail. Hannes will post a link in the description.
And in chat and pin it here.
And in chat.
And here's a little, if we want some, another take on this topic from B-Boo Champ. Come on, Martin. The beauty of the music the MM makes is what it can do with limitation. Not that it can do everything. If you want a machine that can do everything, make music on a computer, not a marble machine.
Yeah, I'm totally with you on that. In spirit, it's just hard at this stage to not be. This is why this decision is so hard. So it becomes more, the more range I give myself on this machine, the more it becomes a music instrument. That's how I feel. But I agree with you. It's the creativity that the limitation is forcing, which is the magic thing. That's why that the original Marble Machine video it's a cool thing. I managed to get a lot out of the instruments we have. It's just, if I want to live with this range as a musician, as a composer, that's the big question. And since the machine is already going to be ginormous, maybe we can make it allow it to be as ginormous as it needs to be.
Yeah, and this is also a cool perspective here. B-Boo Champ continues. The breakdown in the original MM song is so powerful because the viewer understands how the machine works and you make new music in spite of the limitation. That's cool to think about.
No, I totally agree with you. And I have a little like a DJ Restless over my composing. Like
DJ Restless.
I mean, like you can really make magic by just removing stuff as well. Like if you have a simple melody. Let's not make something like that. If you have a simple melody, and then when you just remove that and you just have the bass. Yeah, it was a trick that I did in that video. Like you remove stuff. Yeah, this is really, really, really.
We have our first little submission in the Dropbox folder already.
Oh, cool.
Take a look at this.
Yes, this is the music box way of triggering stuff. Really cool by Joe. No, it's not by Jonah. That's from the
ELES.
Registrator. Turning star cog with quick latch to speed up jump over. This cam actuates second gate. This cam actuates one register with one marble gate. Front view, prog 1. Shift this to change program left, right, prog pin by LS. So if we make the registrators quicker, we still have the marbles have to be as quick. This makes me think of like the audience favorite, to drop the marble directly from the marble gate. This image made me think of that. Let's go and have a look at that. This does not end well.
Come on, Fusion.
My Fusion. Okay, I know how to fix this issue. I'm just going to...
Graphics bug.
Yeah, it's... Oh, then my browser tree is gone. So graphic bugs that I've learned how to fix, but I need to go out of full screen. It's annoying. Hide browser. I should actually show how I fix it. Okay, we'll see. Yeah, to just drop the marble straight from this wheel. But what I think would happen is that the timing will be worse.
Mm-hmm. How come?
Because the speed of this wheel is dependent on the weight of the marble queue. That's why I always wanted this extra step underneath. That is the thing that actually drops the marble. So the registrators, in my mind, is not a limiting factor. The limiting factor is how fast you can replace one marble that is lying still and being dropped with a new that have time to rest and then being dropped. Music is very fast.
You don't say. Mr. Gonsonator says here, droppers and registrators worked fine on MMX, didn't they? It was just the clock that needed fixed.
Yeah. Good point. We should stick with the things that have been validated. Nice to see you here, Gonsonator. Shoof. Engineers assemble. One of the old MMX Gretzky's right there. Yeah, so the clock worked great, but we had 2 releases per track, per note. So that is the thing.
Tried and tested.
Yeah. So let me just go back here. If we're using this G method, standard channel with 1 dropper and extra spots, then this equation is all of a sudden almost, not really, but almost halved.
Mm-hmm.
We can remove Gonger 1 marble releases. Instead we have Gonger 2 music programs. So we have...
The Swinglish is strong in this one.
What did I say?
Gonger 1, Gonger 2.
Oh, sorry. So we're down to this, which looks plus like 10 extra spots. Plus 10 extra spots equals 47. Plus 6 drums. This is doable. This we can do. I know we can do this. Because I've been looking at 55 channels plus 6 channel for drums. Oh, we have the bass as well.
Yeah.
That is 53.
Mr. Gonsonator is wondering, could 2 wheels feed the same final release?
That's interesting. But then they have to be... Still, then we have the... yeah, so here comes another super fundamental design requirement. Marble size. Like, I'm just sketching here. DR marble size. Sizes. So with the marble size I want to go for, it's more of a space issue than it is a mechanical issue. Yeah. So this becomes very abstract, everyone, but what I want to like convey to you is that where I think, sorry for this. So if I save as, this thing comes back. Yeah.
Weird.
It's annoying. But I think this is the biggest like design fork in the road we have right now.
David Mortara tried to calculate how big the machine will be with 148 gates by assuming a realistic gate width. Maybe it's not so gigantic.
Oh, that's a nice one. Let's do exactly, what was the name?
David Mortara.
I'm going to do exactly what you suggest, David, but I'm going to do it for this equation here. So here we have 61 channels, and right now we've been working with an 8mm center to center, or actually 16mm center to center, which would be, let me calculate that, 61 times 16. What? That's nothing.
That's really nothing. 976.
Under a meter.
What?
Yeah. We may, things are smaller this time around.
Oh, wow.
But wait, 16mm, then we... I think on my programming pattern I used, so let's try 9. So 18mm center to center. That's a little nicer for the holes. That would be 61 channels times 18. Still, it's only 1 meter and 10 centimeters. 1 centimeter. We can do it on one machining on the CNC machine.
Oh, damn.
So 10 extra spots as well. But physically it will be kind of tricky. But if we trig all the gates with Bowden cables, the only challenge will be to route the marbles themselves. So then we come to the thing that everyone is excited about to see.
And as Satish Kumar says here, need to account for the marble size as well. Then.
Yes.
Different sizes of the marbles.
But that's why I wanted to have this zigzag pattern here that we talked about like a long time ago. So if I'm going to make a sketch here from the top. I'm just putting points here. So if we don't really see this now. Let me do an offset plane, which is higher up. Boom. Let me do a sketch on that plane.
It's almost time for a break as well, Martin.
Yeah, I think it's a good time to actually...
Because then we can dive deeper into this topic.
Yeah, but then we should change the... let me just see why I can't see the sketch. Is the sketch visibility off? Okay, it's the graphic. I don't have... The button is gone from Fusion because of the graphic glitch.
Great. We fixed that off stream.
Yeah. So we cheated a little bit in this stream by going into the next idea, next subject, and super good suggestions from people. Thanks for helping me think. We have started thinking very high level about this in the design requirements. And we are going to do perhaps follow up on this thing in the next stream. But we got the height done, and we did actually some bonus Vibraphone design requirements done. So we'll take a quick break. What do you think, Hannes? Should we make a new stream, or are we? Yeah, okay.
Let's end this stream.
Yeah.
We will schedule a new one shortly.
Yep, very shortly.
And we'll see you in that one.
Thank you, everyone. Have a nice day.